Hello everyone, and in today's video we will go into the basics of R by exploring heart disease dataset, and we'll do it in the Jupyter notebook. So apologies for a little delay in this R video, but I'm here with this, so thanks for being patient. And okay, we'll start with, since this is the first video, we will start with launching of R. So what you do is you go to this website r-project.org, and here when you click you will be directed to this site. For this, then you go to download R and go to this first link, Cloud R projects. I'm working on Windows, I'll go for Windows, and then you go to this base, or you can just install R for the first time. I've installed it, so you install it for the first time and go for the whatever instructions they give for installation. It's quite easy, and after that the R will be installed. Now after installing R, we have to work on R. So how do we work on R, especially in Jupyter notebooks? To get you started with this, I will take you to Anaconda Navigator. So what you do is you go in your command search tab, and you write here Anaconda command navigator, because you've already installed Anaconda, so you would get this navigator. Click on this navigator, and it will take a little time to open, and just to save time I have already opened this window. So after coming here, go to environments. Your home look like this. And okay, let me tell you a little bit about this. We are working on Jupyter notebook. There's also RStudio IDE in which you can work, and this is suitable for R because it supports certain commands, and few commands are not supported in Jupyter, which I found out. But there are alternative commands which are compatible with Jupyter. So I'm working with Python also. So Jupyter is, I found this very nice. So you can go with RStudio. You can launch it if you want to work with specifically with R. So you can install this, but I am not doing that. I have already Jupyter installed. So now what I'll do is I'll go to the environments. I'll create a new environment for R. So you name that environment as R, and if you want Python package to be installed with this, click on this. Otherwise, just click on R and just create it. My create tab is not been highlighted because I've already created one. So once you create this, it will be created. It will take some time. I click on this, and after, like, it will extract the packages. So like for me, it's like 233 packages are available with this R. Now what I do is this will take a little time. Okay, be patient with this, and since it will take a little time, after installation, I'm just telling you the final results, what happens. And you just click on this, and it will give you few options, whether you want to open the terminal or open with Jupyter notebook. So you click on this open with Jupyter notebook, right? And when you click on this, it will again take a little time, and the Jupyter notebook will be open in your web browser. And if it does not, in the command prompt you will get the link wherein you just copy and paste it in your default web browser. So after having done this, I will minimize this tab, and I'll walk you through this Jupyter notebook. When it opens, it just opens in your local web browser, default web browser, and this is what the home page looks like. Now what you do is you create a new folder for R. So I have already created one new folder. So, and you can also see that whether your R Conda environment has been created, and you just see the list here. Okay, so you're working with Python and R here in the Jupyter notebook. So you create a new folder, and a new folder will be created named as Untitled, and it will be deep down with Untitled. So you open this, and you can just rename it and start working on it. But since I have already created one R folder, I'll work on that R folder, and I'll go to that R projects. I've created this folder. Now, one thing to be noted is that in this directory I'm working, I have to have my dataset loaded in this directory where I will be creating my new notebooks. So I create a new R Conda environment because I'm working on R, and I can just rename this as heart disease prediction with R, or simply heart disease analysis with R. We rename this and we start our project with loading the libraries. Okay, right, R libraries. There's a little difference in the commands with Python and R. Here we simply write library. Okay, first of all, before going through loading library, I need to tell you one more thing, that where will you get this data set? So in this folder, I have this heart.csv, and this file is available here. You can go in this website and you find this kaggle.com. In this, when you open this, you will find this data set, download it in zip format, extract the files, and upload it here. So I think these basics are being known because it is same for Python and R, and we have covered it in various videos. It has been covered a lot. I will not go into much detail in that. So you just upload this file here, heart.csv. I'll be working with this file, and this is where you can extract that. Okay, now we come to this heart disease. Now what will we do is we will first of all, let's just load this library, and this library is I will simply write library, and this is tidyverse. Okay, and hit shift enter, so it will be loaded. Okay, so okay, now can you see this? It's been giving me packages with this library, so I can work with ggplot2, tibble, tidyr, readr, and dplyr, and we've got dplyr also. So this dplyr is for data manipulation, as pandas is for data manipulation in Python, and dplyr is for R. This tidyr it will simply clean up the information. ggplot is for a visual representation of your data. So we've got some basic packages here to work with our data set. Now we come to something good. Now let's store our data. So for data, I will store this in, now instead of equals to, the R uses this sign, which is an assignment operator here. This will just store this data, whatever I'm reading, that read.csv file. What is the name of my CSV file? Is heart.csv, and this would be read into this data. So this will store this into this data, and what I do is I don't if I write simply data, let's see what happens. So you can just see this, the entire data has been loaded, and when you just scroll down, it will not load the entire data set, but yes, a few data would be loaded. Now if I just want to check a few data, so I'll just write head and data. So this will give me this head of the data, like a few values. Okay, first 5 values are by default. There are 6 values actually by default, right? And similarly, if I want to check the last values, I'll simply write head.data. And in Python, we were writing data.tail, data.head.df, head. Like that. Okay. So I just enter this, and we got this. Now, if I was working with Python, what would I have got is, I will just show you. We just check it through df.head, right? We do not write it head and then coming to the command, but here in R we are doing simply tail and data. Okay, easy, no dot, nothing. Another thing which I want to show you with this is you can also write here glimpse.data. Okay, so what does this do is glimpse data. This will give you a glimpse of the data, just to give you a rough idea about the rows and the columns. So we've got 303 rows and 14 columns of features, which it's calling as variables, and you can see these variables. So the details of these variables are already been told in the previous Python analysis lecture, but yes, I will be going through it once again, like age, sex, CP. This is, you've got cholesterol, you've got fast beating, this thing, and I can just tell you about further description of it from where I've written that. This is fasting blood sugar, and it is a binary type which is greater than 120 and less than 120. And we'll be working with these variables, so just get a little familiar with it, that you've got chest pain, and this is 4 types of chest pain which has been mentioned here. And resting blood pressure is resting blood pressure. And this is thalamium stress test you have, and this measures the blood flow to the heart with possible values, and you've got certain values here. You've got age in years, sex here. If you just see 0 is for female and 1 is for male. So remember this thing, that few variables are binary, few are numeric, and we've got a mix of data set here, okay, which we'll be working with. And this is what exercise included, and again it is in binary, right? Okay. So now what I want now is that since I know that there are 303 rows and 14 columns, another thing in which I want to show you is how do you really extract these rows and columns without having to know this. So you can just simply write here n column and of the data. So it will give you 14 columns. You can write here n rows. That means number of rows in my data. Simple. It is 303. So just it's so simple, no, when you write and you are just getting the results. So just good. You don't have to worry about so many syntax and columns and colons and etc. So here you've got column names, and I want to just retrieve the column names of my data. So I just write here, these are the column names of my data, and I get these 14 variables that I'll be working on with my data set. Okay, right. Now, another thing here, important thing is that I want to tell you about okay, I want to tell you about data transformation in this now, because I'll be working and I'll be showing you the difference also why we are doing this. Data transformation. Okay, transformation. So actually this is a big code, so let's just bear with me. So in data 2 or data 1, whatever you want to name it, I will just assign this as what? Data. And this is how I write the syntax as percent, and okay, I'm giving it information. And what I want is I want to mutate it. So this is a big code, so what I do is I have already done it before, so I'll just okay, I'm not showing you one thing. Okay, I'll just do it. All right, I'll explain this code, but just be with me. Okay, so now one more thing I want to show you here is we have one more command which we can use for data exploration, is summary. Okay, summary data. So you get here statistical information regarding your data, and this is like this includes objects also, or categorical variable also. So what are these statistical values that we get here? It's minimum, maximum, first quartile, third quartile, median, and mean. And you can find here of this, let's just examine one now. Okay, let's examine this cholesterol, and the minimum range for this cholesterol is 126, and maximum you can see it's 564. So there's a huge range, and I can figure this thing out from this median, that the median value lies in somewhere 4 to 40. That means there is a huge range between minimum and maximum, and there's a possibility that outliers are present here. That means extreme values are present here. And similarly here in this thalage, this is the thalamium test which is being performed here. It's like minimum is 71 and maximum is 202. So that means this can give us a little information that yes, the patients suffering from heart disease have got some maximum thalamium or something, and they have got maximum cholesterol or something. And so this is just a basic overview of the data set which we can infer from the statistics, the numbers which is this conveying. And okay, so 25% values lies in like 133, and so that means it is quite low, and people would not be getting heart disease here. But third quartile, it's like 166 it becomes. Okay, so similarly you can just examine it for different variables, right? Okay, so this was this thing. Now I'll come to data transformation. Now what I'm doing here is I am mutating this thing. Mutating means since we know that in males and females it is binary and it is 0 and 1. I want it to be converted into, I wanted my data to be recognized 1 as male and 0 as female. And that is what we have seen before, that it is binary but it is in 0 and 1 form, wherein 1 is male and 0 is female. So that is what I am writing in here. And I wanted that if, as I'm applying here, that if sex equals 1, it will be male, otherwise it will be female. Similarly, it has been replicated for FBS, that is fasting blood sugar. If it is 1, then it is greater than 120, otherwise it is less than 120. Okay, and what are the values we have for this? 1 and 0 again. Then you've got it for X, I don't know what is this, Xang, I think I'm forgetting this. Okay, and again we do this for yes and no. So if it is 1, then it is yes, and if it is 0, no. The same thing we repeat with various variables, wherein we find that they have got some values. And why am I doing it? So that later on the data visualization becomes easier, because I've done it without using this thing, and I'll show you how does it look without doing this mutating function, without applying this method. So just do this for chest pain, for resting sugar and resting this thing, for slope, for CA. This as factor, that means it is for it is a data type in R, and that's what we are doing. And for target, I've applied that if target equals to 1, that means you've got a heart disease, and if it is 0, that means, and whatever the value remains, that means no. So this is how it will infer the information, and will replace this values, these 0, 1, 2, etc., to these more readable human format, like it is male or female, or which pain do you have, or what is the target, like yes or no, right? As compared to 0 and 1, and then we are referring like 0 means this and 1 means this. So this makes life quite easier. And then what I do is, this is mutate, that means I will change this is character as dot factor, and this is I told you that this deployer is used for data manipulation here. So I'm using this deployer with the semicolons, double semicolon, double colons, because this is how the syntax works. And what do I manipulate? I manipulate this target, and I manipulate the sex, FBS, Xang, and whatever variables I have written and everything. Okay, so this is how I go with this. I run this. This has been done now. Next, our step will be coming to data visualization. Now you will not get any output for this, but this has been done with inside, right? This has been already processed. Now you will see the results about what and why we have done. Now see the magic. Okay, now in data visualization, I will plot something like, let's just go for a bar plot. So what I do is I post a comment that bar plot for target, because I want to see how many and this is heart disease. So let's just bar plot for this. So I will use ggplot here. ggplot is used for your data visualization in R. And if I was working in Python, I could have used matplotlib, Seaborn, or even plotly for that. So this is axis. Now this is basically giving you a figure with axis x and y, and I'm just defining these axes as like x is data, and where you want to go this data, in this data, that means my data, and I wanted this dollar sign will take me to where? Target. Okay, so this is what it does, and I will fill it with what? I want to fill the data. Have I taken this data 2? Yes, this is data 2. Okay, this is correction, like this is here also data 2, right? Okay, and data 2 dash dollar sign target, you fill this target. Now what I do is I will concatenate plus sign, because I want to do more things in this, and I want to do it inside ggplot. So what I do is I go to here and I use this GEO GEOM underscore bar. Now what does this GGOM does is that this is nothing but simply this tells the ggplot which plot I want. I want a bar plot. Suppose I wanted scatter, I could have written scatter line or box plot. So this tells you which kind of a bar or a plot you want in this ggplot to be plotted. Okay, how you want to display your data. This is what it does. Then again, I wanted bar. Then it is a simple plot that we'll be doing. And then what we'll do is inside this block, what I'm writing is I want this X label as, let's give it some label so that it becomes quite presentable. And this could be heart disease. And again, I will concatenate it. And then I want Y label. What is the Y label? This Y label is simply, it can give me a count because it is a bar plot. So you give me the count of it. And then I go to GG title. So the title would be, okay, I can write the title as presence and absence of heart disease. So I can just write here count of presence, but let's make it simple. Presence and absence of heart disease. Okay. Now, if you want to concatenate another thing, so let's just concatenate one more thing and be done with it. And I will concatenate scale. And what do I want to fill? I will write here dot discrete, and I'll give here a name. What the name is that? And this name is okay, heart disease. Labels is I will concatenate. C is for concatenation, treating both as one, like absence and presence. All right. Okay, I have missed one here. Absence and presence. Right. Let's just run this. Okay. Cool plot. This is a bar plot, and if I show you little less zooming in, and let's see this bar plot. This is the presence and absence of a disease in our data set. So if I had not mentioned here no and yes, it would have given me 0 and 1. This is like mapping it. I am just converting. This is called coercion in R. I am converting those 0 and 1 into this categorical data, that is no and yes. Okay, so that this becomes quite interpretable, and I can interpret it like, yes, this no, that means this is the absence, and here it is the presence of the heart disease. And you can see the count that there are more cases of getting heart diseases, I mean the patients having heart disease, and those who are not having heart disease. So let's just explore it. Okay, I can just zoom in. Yeah, so now just do it. Okay, now let's come to another thing, and I just want to show you one more thing. Let's come to now, since we know that this is the count of the people getting heart disease is more as compared to not having disease, let's just find it out. What is the proportion? What is the ratio? So I do it with, now where do I want it to go and find it? I want it to go and find it in the target variable. So this $sign will go in the target variable to search for this proportion, and it will let me know that for no, it is like 45% of the people are not having heart disease and 54.4% are having heart disease. So the data is not that unbalanced. It is quite fine because it is it's okay, like, but it is more bent towards the people who are having heart disease as compared to not having heart disease. Now another thing which I want to show you is let's just count the frequency. Okay, just count the frequency of the values of age. Let's just explore this age variable. And where do I want to go? I want to go in my data 2, okay, which I've created, and I just use this is a syntax for that. Now I go to, in this block I want again I want to group. What do I want to group? I want to group by. Now here's this I will mention this value and this age. Now since we have got this age, I will just go and copy it, because this age, as you can see, is having some, I don't know what, I dot dot and age. It's written in some different format. I'll just go and copy it. Okay, see, as you can see this. And what else do I want? And it has to be same, this column name, whatever the data set is having, my data frame, I have to have the same thing written here. And here, just notice one thing, that I'm not using any kind of quote unquote or any quotes here, whereas we use it in Python, because it is quite simple. You just write it and get it. So it's good working with R, right? Okay. Now what you do is you count what I want to count. I want to count, and again, I just want you to give me that count. Give me that count. Okay. And filter. N is greater than 10. Okay. I'm applying a filter here so that it makes more sense. And then what I do is I go for ggplot. You plot this data, and now I will use plus, because in that plot I want to do certain things, and I want this kind of a plot from GOM, and I want this columns. And then what I want is, okay, axis. I could have defined it above also. Now what is this I? Let me just paste this variable here, and this is n. That means it will go iterate the number of times, number of values, till the number of values. Then what I have here, why I'm getting two this thing here? Okay, it's just one, right? Okay. Now you go to fill, and in fill, what will I have? Fill the color with, like, suppose green. Okay, and then plus again. Now I go to GG. I'm just filling it to make it more presentable. You can just skip this if you don't want, but it just makes things a little more easy to read. That's why you can just do that. So you just age analysis. This is just simple age analysis, and then again you can concatenate that with X label and Y label. So you can just do that X label. In this X label, I can have this age, and then again I will concatenate it with, and I will write it just simply Y label, and here is the age count, right? Or you can simply write age or age count, whatever, and just shift enter. You will get this. Okay, this green is quite bright. Okay, so I'll just again zoom out. Right. So you can see the age count, and you can see the gap here, like 45 to 50. You see this gap here in this analysis of the histograms. This is a kind of a count plot. Count plot is a histogram for the categorical variables, and they give you a count. You can really count that how many people are falling in this range, and what is their count here. So most of the people are like in the range of, like, here 55, more than 55 to 60, and you can see the count here. So the data set contains the people who are more elderly as compared to on the lower side. So this is skewed towards this on the higher side. So this is where the count is. Zooming in again. Okay, so now we come to another part of it, and I want to show you something with the box plot. Let's just since we have done a lot of data transformation, let's just compare it with, like, compare blood pressure. We will compare the blood pressure across the chest pain, right? Or pain type, or chest pain, whatever you want to write here. So where I wanted to go, into data 2, and in that, what it will do is ggplot. Okay, I'm just calling it again. It is widely used library in Python. Excuse me. Here you will go to axis X, And what I want in X is, I want in X is X, I want the gender, the X, the sex of this, and in Y, I want the, let's take trust BPS. Okay, this is what it is. Okay, I wanted to show you this thing, trust BPS. This is trust BPS. Okay, this is the blood pressure that we are taking in now here. So I take this on y-axis, and this will be, then I will be concatenating here in this, and then I will give it a type GOM, and I want a box plot for that. So I'll take box plot. What I'll do is I will fill which color I want. Let's say I want a purple color for that. So I'll take purple color and add this, and then again in this block only I will use this X label, and X label I can, sorry, it's not equals to here, and then I will write here sex, and in Y label I will go and in this block only Y label I will have the blood pressure, and then what I want, since it will be across this chest pain, I will plot a facet grid here because I want to show many things, right? So I will plot this facet grid, and I want it for my entire chest pain, so I will plot this now. Okay, here you go. Okay, so now you see that we have transformed our data set, and we have given various different names for this chest pain, and we have mapped the number to different types of pains like asymptomatic, atypical, non-anginal pain. So this is being plotted as per the chest pain, and the variable I have used is for sex, males and females. So for females I can map this chest pain, the kind of chest pain, and the counts. Is there any outlier values here? But in males I get it, not in females I do not get it in females. Here if you see this atypical angina pain, sorry for the pronunciation, and here I will find here the females having this blood pressure and the pain, and in males also I see few outliers here. So that means that this is more consistent in females as compared to males. The males are like getting chest pain, this blood pressure is really high, it's shooting up above 190 180, it's going to like near approx 190, which is quite high in males. And you can see it in here also, the type of pain and the blood pressure associated with it, and it is on the higher side, and the pain is also like this on the higher side for males as compared to females. Okay, so now I want to show you one more thing here. Suppose I don't use it, and I just copy this. I was just experimenting with one more thing. What if I don't use this data and I use it with the initial data I have, and I plot this? Okay, now you see the difference. I am not getting any male female division here to understand what does this box plot signifies for who is getting what kind of pain. I don't know. And you can see here I'm getting 0, 1, 2, 3 instead of the name of the pain. So you compare for yourself which data visualization is more meaningful and which one is not. Here I am getting the entire data for male and female combined, and it is giving me the information of the outliers, but I do not know this outliers belongs to which category, either it is male or female. And here I could easily determine that more outliers are present in the males. So I can tell that males are having more high blood pressure. They are inclined to get more pain in their chest as compared to females because of the rising blood pressure, right? So this is why we were transforming the data here, and I can use this transformation of the data with different data visualization and manipulate this as per my need and show the effect of what we did. So this makes more sense as compared to a simple graph, a simple plot of box plot, showing you just a division of sex, and I don't know what sex is this, male or female, and I also don't know what kind of pain is this. I'm just getting the values, just the numbers. So if you want to convey this result to someone who's just who don't know or who does not know how to interpret these things, so this makes more sense, right? So now we come to something different. Okay, we've done the box plot. Now let's go to if you want to experiment something more with box plot, I'll just show you one more thing. I'll just copy paste this thing, and I will not use data simple data here. I will use data 2 here, and in this ggplot I will use x, but in y I will change the variable and I use the cholesterol here, because I have also played. Let's play around with cholesterol here, and I can use this as like orange or so if you want. I hope it is not that bright. And here in this y label I will use the cholesterol, and here instead of okay, facet grid could be chest pain itself, and I am going to plot this. Okay, here you are with the chest pain and determining the cholesterol level. So this y-axis just keeps on changing. You can experiment with this y-axis. Here I have experimented with cholesterol level of the gender, across the gender, male and female, and according to their cholesterol level, what is the type of pain they are having. So this is how you interpret this figure. And in the previous one, what I did was, okay, so you can see this figure. Okay, so according to the cholesterol level, you can see these males which are having pain and not having pain. So it is like approx, like, you know, more than 400 or so for females. So this, there is the cholesterol level in females is more, but here you can see that it just goes, yeah, it is more for females here also. So like males are having it but less as compared to females, and I can see the lines are also, the skewness line is also big for females as compared to males. So this box plot is not symmetric as such, but is skewed, and is also outliers are present in the male data set here for non-anginal pain. And here we were finding it out for the blood pressure, and you can change these variables depending on your choice. You can use it for chest pain, you can use it for various variable that we have converted, you can use it for restec, slope, you can use it for fps. Okay, so if I do for, let's go for a correlation here, and this correlation, okay, so for correlation, if I want, I have to firstly install the packages, and if it is not installed with you, just install these packages so that we can work on this. And you have to install this correlation plot. This is not inbuilt in the R. You have to install this package, and this has been provided from the third party which provides packages for R. These are free packages, and you also just plot this ggplot2 also, just like this is install this. Okay, and since it's installing, let's just write another command here. We'll write here library, and we will use correlation plot, and here we will use library and ggplot2, right? Okay, so this will take a little time. Okay, so this has successfully, this spelling, okay. So again, now since it is an open software, open package, it is likely that the versions can change, and also updates are available, so we have to keep on updating with this. Now if you're not aware of certain things, what you can do is, I'll tell you in a while. Let's just first plot this correlation of heart. I want to show you something really interesting here, and in this I will use the correlation. I will go to my data 2, and where I want, I don't want the entire features. I just want for few features, and I will do that. And here I will use this correlation of the heart. And what you do is, in this correlation CORR plot, I will use here correlation plot. In this correlation plot, I will plot this heart, correlation of heart, right? And I will use method here, what method I want, and I will take here square. You can use different methods like circle or ellipse, and there are various types which are available, and it can be upper, it could be lower, it could be different types. Now you just shift enter and you will get this square. This is what I mentioned, that I wanted it in square. And as you can see, this is upper, and what happens here is that you get this table here for this numeric data, and you find this correlation here, and you can map this correlation. So first let's see the figure and then we'll come to the digits. This figure can let me know with the help of the colors that which of the features are really correlated and which are not. So as you can see, this navy blue dark color represents highly correlated, and this is among the variable itself. So this diagonal has to be like 1, that's perfect. But what if, so I don't see here that strong high correlation, but I can see fine fair correlation with this cholesterol and the age, right? I can see this negatively correlation with this thalmium test and age. As you can see, it is negatively correlated. So this color can also help you determine the direction of your correlation, and also the strength of your correlation, positive or negative, and the numbers speak louder, because now you can see that negative correlation with age, and that's what we have seen, that this thalmium test has got negative correlation with among all these variables. Okay, you can increase these the size of your columns for getting more correlation. I want to show you one more thing of this method and square. How can you change it? So what you do is, if you really want to see that thing, just write here question mark and method. It will direct you to, and hit shift enter, it will direct you to the documentation, and will open up a separate tab here, and this will load, and let's see what it gives us. It is a support document from R to help you understand what this method really means and what all methods you can apply in your coding process. So just one more thing, and I want to show you this facet grid, facet grid, if you want to. So this is again in the R documentation for facet grids. If you want to read more about it, it is here. And what all are the arguments you can pass here, the scales, margins, the facets, and how it is really being displayed. We have done one video of facet grids in Python. I'll provide the links so that you can go through it once, if you're interested in Python. Yeah, provided. This is taking a little time. This will take a little time. Okay, I have already done this before, so I'll go quickly. This is what the page will open like, so just take a time. I was talking about the third party which was providing the packages. This is CRAN. This is an archival for R providing you the packages, and you can see here the various features that you can just experiment with, and this is what we've done. We have used this library CORR plot, and we are seeing the methods of it. It has got circle, so this is how it will be plotted, and this is the full matrix, full correlation matrix, which is being plotted here. This is the square, but we have not taken all the square here. We have just taken the upper part, since if you had taken the lower part, the above part would have just gone, right? Okay. This is the ellipse. You could have taken this ellipse also, and this could have just shown you different ways of representing the data, and you can interpret the same results because it is all the same, but just the shape, the visualization differ. And if you're not interested in any of these, you can just plot it with simple numbers, and this is what the number display is. So you can just experiment this with different types, different methods, different shades and colors, and see the things change for itself. And with various projects we'll be experimenting with all these things. So this has got, the layout is like full upper and lower, and you can use it to make your data more representative. And this is like the entire thing. You can just go ahead, see with various colors, experiment it, and I think this is good enough to work with, give you a lot of options and diversity. So this was about this video, and stay tuned for more upcoming R videos. I will be posting it, but be patient with me because I am working on certain things, so it might delay, but I will come back.